This is Mitchell Gumko. This is week 13 for geology, and this week we did another experiment. We did an experiment where we had to go out in the field and make a discharge. So kind of like a flow of water going out and discharging things, and it was actually really fun. It was really cool, interesting. It was fun to get back out in the field and do stuff and do some actually interactive work with like your hands and stuff outside. And the weather was quite nice when we did it. um, so for our lab, we took a piece of tin foil. We did it as a group. My group, me, Nate, Kenzie, and Grant. We all worked on it together, and we used a piece of tin foil, and we just kind of make a channel with it. And we had a hose flowing water down it, and like kind of was on an angle too, so it was going down like this. And we used golf balls, not golf balls, ping pong balls, for the objects flowing down this discharge, like going out of the water to get discharged into whatever it was going into, just a pile of rocks, but whether it's something else, like it doesn't matter. But so we the variables that we changed were we were changing the width of the channel. So we started with the we had a 4-inch channel, then we went to a 2-inch channel, and we were changing the width of it because we want to see how that would affect the speed of the objects moving down the channel, moving down the water. So we took the width of what the channel was, so the tin foil, and we had one that was bigger, about 4 inches, and we had one that was smaller, 2 inches. And we kept the constant flow of water. We didn't change how much was coming out of the hose or the angle of anything. We kept the angle the same, the length of the channel the same too. But we want to see if the width would affect the speed of the objects moving down there. So when we made the width, when it was a bigger width, when it was 4 inches, it was slower. Then when it was a tighter channel, it was faster. The objects moved down the channel faster actually when it was a tighter channel, which makes sense because there's not as much room for the water to spread out, so all the water is staying compact and flowing down faster instead of spreading out and not having as much power behind and kind of like lower level, so it's not as like filling in the channel when it was wider because it could spread out more. More could be more could be spread out and cause not as much speed, I guess, like you could say, through it, but the tighter it was, where it would go down faster because it's all compact. And I mean, the variables that were not changed and that were fixed during this whole experiment were definitely the length of the channel because we kept those the same, so we didn't want to change that up. And then also the water was running. So like the speed of the water, I guess you could say, wasn't really changing per se, or the amount we were putting into the experiment, because we just kept the hose in just had the hose for the water, for the flow of water. So it wasn't like one channel was going full pressure and the other channel was going no pressure. No, like we just kept it at the same time and didn't change the pressure of the water. So that kind of helped just really simplify or make the speed really right on the width. We were able to find, because the two factors that played into the length of the channel and the water, that was the movement in the side of the channel, was able to stay fixed, and we were able to see if it was actually true that the width could change to speed. And I mean, as you see in the video, you can see that this one, I mean, it's hard to tell which one goes faster, but I mean, obviously, it's it was like a little, like, point something seconds. I can't remember exactly. It's in my notes, but I should have wrote it down instead. But yeah, but it was really fun. It took a few tries, to get it down, to kind of experiment what we were going for and what we were thinking about. And it was just cool to go out and do something again, and it helped that it was really nice out, and it was cool to see discharge in life, or in first person, I guess, and kind of control your own discharge. So it was a good experiment overall, and it was fun to do it with the whole group.